So thanks for inviting us out, guys. My name's Don Foster. I'm the Director of Product Management for CommVault. I've actually been with the company now for about 11 years. I've been in IT prior to CommVault. I actually was an SE back in the days when CommVault was a little bit smaller than we are today, back when we had to do the implementations and the selling and whatnot, all as one as an SE in the field. So I've managed SEs. I've been moved into product management in the last 5.5 years or so, and I effectively run what we call the modern data protection solution sets within CommVault. So that's anything that we're doing from a snapshot integration perspective, ways we leverage with VMware, Hyper-V, and other different hypervisor solution sets, how we can manage and protect applications, drive even some hardware array-based replication components, as well as even some of the neat stuff we're doing on edge with tablets and laptop desktop protection, and just some of the ways we're helping to make data more accessible. So I was hoping today what we could do, I know being VMware and whatnot, it'd probably be good for us to go through some real good high-level architecture sessions, then dive deep into what really makes us different, not only as a company, but what makes us different in how we attack those hypervisor-based environments. So from my perspective, I hate it when a room is silent. So if you guys want to drive me crazy, you can just be silent the whole entire time and act like you're not out there. Or if you want, fire off the questions as we go through this. We can go down whatever rat holes you guys really want to, whatever points and tangent lines. I've got no problem with it. We can talk through kind of the solution sets and the different capabilities that we can offer for the customer.
Have you been to a tech field day?
I have not been to a tech field day before. So I'm going to enjoy this, I have a feeling. So I guess high level on CommVault. If you don't know who CommVault is, the internet's out there. Google us. We have a web page, believe it or not. You can find out all you want to know. The core differentiation that we really drive, though, and this is really what makes us different from anybody else that might be in the industry. What we've done from our platform, whether we're talking virtual machines, physical machines, cloud-based storage, applications, you name it, what we've done is we've organically grown our platform from the ground up. So we have not gone out and acquired technologies. We have not gone out and tried to find a solution of the day that we can try to loop into our software portfolio. We have developed it internally, so we have true organic growth. So what that effectively means is, just to give you a couple quick high-level views, right? From a Sympana perspective, and we've been around for about 11 years now. Well, actually, I'm sorry. We've been around for much longer than that, but the product, has been around for about 11 or 12 years now. Sympana drives this back-level platform. And this platform, once you buy the software for whatever use case, backup, archive, replication, VMs, cloud management, e-discovery and search, a whole suite of different use cases. Once you buy this platform, it's just a matter of actually turning on agents and functions for things like backup and archive, replication, search, e-discovery, you name it. The key part about this is this platform's extensible, right? So our backend infrastructure is effectively just a SQL database that does all this top-level meta management. I'll kind of explain what that means and why that's important, because it drives this idea and the concept that we call a content store that allows us to take data that's been archived or backed up and almost leverage it as more of a live data repository, not a dark data or a just an insurance copy stored somewhere back in your data center. All right, so we really give the customer an ability to take that information they've protected, those points in time, and start to leverage them in other use cases, things like refreshing dev and test, or really driving disaster recovery test scenarios, or potentially even mining that information for end user access. Great use case. I don't have it up here with me, but I've got a tablet that we have a CommVault Edge app for. That if my data is protected, and I love it, it shows like at VMworld, I can take the tablet to the floor, put my MiFi in my pocket so I have web access, and any customer can come up to me to talk about whatever topic they want, and on the fly, I can access all of my materials that I have on my laptop right there from my tablet and open up and walk them through presentations, white papers, what it is they need. And that's part of the key what this whole content store idea is, right? So we provide this platform. This platform enables all these technologies. You can turn them on. And of course, inside that, we do a lot of media management information here, right? So I have my own deduplication engine that I do from a software perspective. I can do source-side deduplication across all the different mechanics of how I drive data management, data protection, and archiving. So source-side dedupe, all the WAN network bandwidth efficiencies, storage efficiencies, and of course, we can write this to any type of disk, tape, cloud, and of course, even now, we can leverage snapshots and production storage as a part of these repository locations for data that lives inside of our platform.
Is that source-side deduplication per device or VM?
It's global to the entire solution.
It's global to the entire...
Now, there are scale caveats in how far you can go. So one of the key things is, recently we launched Sympana 10. So quick backstory on CommVault. Sympana 10 was launched in January of this year. Okay, in Sympana 10, we're already effectively in like the 4th iteration of our deduplication. The real key thing that we launched in version 10 back in January is the ability to actually let 2 deduplication nodes work as one. So you guys remember some of the appliance guys trying to do some of the clustering with their appliances. So they could let, for example, I could let appliance 1 and appliance 2, who might be sharing the same backend disk storage, truly provide one global deduplication namespace. You know, there were companies that were trying to go down that path, and inevitably they changed their direction. Well, effectively what we've done here is we can take what we call our core, our media agents, and our disk targets, and from a deduplication perspective, I can have media agent 1, just think of backup server 1. I can have media agent 2. These guys each have their own hash tables or deduplication databases that track what's unique, what's not unique, and they can share a backend namespace, an Isilon 1FS, a Netapp NFS store location, right? Any sort of NAS or even fiber channel or iSCSI direct block disk targets. And based on how we're doing this, our platform allows these two to basically be interconnected. So data that flows in from client A or from client B, if they have don.txt stored on both of them, we're going to ensure that we're only storing that file once. And because we're allowing 2 media agents to work together, we've effectively doubled our performance and doubled our scale in how we can grow the back end. So net result here, this federation, the ability to start scaling out nodes in a grid sort of deduplication environment on anybody's hardware, leveraging our software. What's that?
That sounds like target dedupe, not source.
The way the actual DDB is being scaled out is the actual backend hash table. When we do our deduplication, when client A is protecting its information, he's hashing that information on his side. Those hashes get batched through into an actual check-in process in stream, together with the files and information from client B. Because this is that central repository location, they check in the hashes. Depending on what information that we're seeing, if it's unique or not, it will then iterate to the client which blocks or which data sets to go ahead and pass back through the architecture. So if 90% of this is not unique, then only 10% of the data will be actually passed through as unique segments to that actual backend infrastructure. And the parallelism that we're driving here allows for 2 times the actual capacity. So with today's setup, it's about 240 terabytes of backend dedupe capacity on that 2-node setup. Multiply that by your expected dedupe ratio, and that's the amount of actual front-end data that this software infrastructure can handle. And of course, you can add multitudes of these as we go. So that's just a quick high level on dedupe. Right? That's one of the core things we can do in the platform. But it's not just dedupe, right? It's virtualization. It's also driving hardware-based snapshots. So from a hardware-based snapshot perspective, you guys maybe heard of IntelliSnap or Snap Protect or Snap Backup over the last couple of years. It's one of those things that we've developed. It's actually one of the core things that I've been managing from a product management perspective, where we've gone off and we've worked with EMC, IBM, HDS, new guys like Nimble, and a slew of others, obviously the Dell folks as well. And we've basically taken all their snapshot APIs. The ways that you'd work with a VMAX, the way a VNX ties in with VNX snapshot, or even the older Clarion or SnapView snapshot mechanism. We've basically taken all the controls and mechanisms that you would need as a customer to write a script and drive that point-in-time snap or that point-in-time clone, and we've automated that inside of our software. So what this allows us to do is basically take for any of our applications that we're managing from a backup perspective and drive instant point-in-time snapshots that live inside the array. They're application consistent. We manage the retention. We manage where that information can be brought up to and made available to. And then, of course, at that same token, we can recover quickly from that harbor from the snap. So we can initiate rollbacks, reverts. You can even do the mount and go sort of idea if you just want to make a volume live to do a dev test type of refresh. So these are the core things that we're doing from one platform. We've taken these technologies that others have acquired from other software components, other software companies, and we've linked them together because we've effectively got the single backend architecture, the single data mover or media agent that functions for all of this. So encryption, compression, all the policy management, job scheduling, that's all done from the same location, the same platform for management. The benefit now then, yeah, go ahead.
So back to the deduplication part.
Sure.
About the clients.
Yeah.
Can you clarify what constitutes a client?
Client could be a client could be a Windows file server. It could be a Linux file server. Could be an Oracle database server.
I see. So it happens in the actual source.
Bingo.
Got it.
You got it.
This agent-based?
What's that?
That's agent-based?
It is agent-based, correct. So the reasons we need agents, right? The reason we leverage agents, everything from Oracle to even virtual machines, whether you're talking VMware, Hyper-V, right? Even down to things like SQL Exchange. If you're just doing basic calls to an OS, if you're just making basic VSS calls, where you're querying the whole VSS infrastructure so you know you've got something consistent, you're really not going to be able to take advantage of all the content tracking, all the granularity for recovery by just making these simple little calls and trying to maneuver the files themselves. All right? So we make sure that from our viewpoint, we're going after this data from a top-down view, which is also how we change up the idea what a snapshot is. Most storage vendors, take Netapp for example, will give you a bottom-up view from their snapshot methodology. So they want to know what LUNs, what volumes, what physical devices you've got defined, and then they'll take a bottom-up view and basically, well, we're going to snap the volume. You kind of figure out how you're going to make sure that app is in a consistent state, and then tell us to go, right? Whereas we're starting at the top and saying, I'm going to know when the app's consistent. I'm going to know where the log volumes are, where my VMDKs might be stored, where my databases might be stored. I'm going to make sure I encapsulate that all as one full group. And then I'm going to go down to the storage and make the API calls to understand which volumes or which LUNs associate to that, and then call the snapshot or clone or the break mirror from there.
You have the ability to define multiple separate applications that work together and snap it together?
As a consistency group, not quite. We do have the ability to execute them at the same time, but the industry defines consistency groups as knowing that these 10 logical volumes are all snapped at the same given point in time. We can tell you the process will start. They may be within a couple seconds of one another, but we don't have the mechanisms today to provide that true consistency across all 10 related volumes or objects at this point yet. Okay. So in most cases, that's okay, because most applications anyway have the logging function. So you can roll things forward and back. It's as long as you have things that are consistent, it's not too difficult to get a solid state across that application. That makes sense? So the other interesting thing here is we talk about access, right? So while we do have one interface from a main management perspective, we understand that you can't do everything from this massive control board, right? You guys ever remember there was a game back on the original Xbox, Steel Battalion? It was this huge army box. It cost about $350 because it had this controller that had literally about 400 different buttons to it. All right? I actually pulled this thing out for my kids the other day, and we sat down. I actually bought this. I kind of was a gamer back in the day, still am. And my kids sat down, they looked at it. They couldn't even figure out how to make the whole thing work. Looking at all the buttons and switches, brought back the standard Xbox controller. They're like, okay, well, now we can go play the different game because that's just too complex. And we get that. Same sort of idea from a manager perspective. If I am a Oracle DBA, probably all I want is a way that I can get into RMAN through a command line, execute all the different RMAN commands, call my log backups, call my database backup, whatever that might mean. And that's all I want to see. I could care less about a GUI. I could care less about all the whiz-bang credentials it's got inside of it. I just want to get my job done. That's what we're enabling for our customers. So we have interfaces for end users that have laptops. We've got mobile apps for monitoring it, provide dashboarding from any location, right? We can give VM admins plugins inside vSphere or inside vCenter so they can link in directly what's happening inside the virtual machines, right? We're continuing to drive more and more down that path, even with the ideas of creating some specific interfaces for DBAs. So that if they want to do database rollbacks and have something that's specifically driven for them from the platform, those are the whole ideas that we drive by. We want to ensure that we can take this platform and the content store that basically drives all that information and make it as available and accessible for our customers as possible. Okay. Now I've mentioned the content store a few times. I'm going to erase this. Any questions at this point? No? Okay. I apologize for being the fast-talking Chicago dude. You're lucky I couldn't find a monster up to this point, or I'd be going about twice as fast.
So, this content store.
Yes.
What's actually in it?
Great question. So, when we talk about the content store, it's actually just a name that we've associated to all of our storage targets. So whether it's disk, tape, deduped or non-deduped, appliances, cloud, even data that's inside snapshots, it's basically a name that we're labeling to all data under Sympana control, or under Sympana management.
But you do search and e-discovery, so it can't just be that.
Well, so the search and e-discovery you can turn on for different data sets.
I understand, but what is part of that?
What is part of the search and e-discovery that's defined by you as an end user? So let me walk you through it. Let me walk you through exactly what I mean by
No,
this.
I mean, is it just metadata?
The content store is actually the data. The metadata, there's actually two components to it. The level of meta information that tells us all the info that we're collecting, and then the actual physical data as it's structured on disk, tape, cloud, snapshot, whatever it might be.
So that's fine. If I have 10,000 employees, I have 10,000 mobile devices, I back them up into using Simpana, I now have 10,000 different things. I want to search for the one that's actually made the calls to China. I now have metadata about everybody, and that could be part of that metadata.
Correct.
So it could be a very, very large data set.
Correct.
Now, search is relatively optimized for things like that, but what if I wanted to farm that for other things using big data tools? Could that be done?
So theoretically, yes, that could very easily be done.
Then how do you protect the privacy of the individual's data inside of that big data set, including search? How do I prevent the average user from actually searching for something that is not their right to search for?
Because when they have the access points that they have into the data sets in the content store, part of the metadata, so there's three levels of the meta information that we're collecting. And bear in mind, so think about it this way, right? What's a file system? File system is nothing but a blob of information stored on disk that has some form of access table that defines what you can see, what bits to pull back, and what rights you have, right? Mm-hmm. The content store is effectively that same sort of idea. We're writing all this information on storage. It's just a bunch of blobs of information that's being written across different storage mechanisms. But we're showing and tracking out who has rights to what as we collect the information and store it into the content store. So if I give you access rights from a web console to restore your data, I can say that you only have access to the one laptop that is truly your device, which can be defined when the device gets implemented, and ensure that any search terms that you execute only occur against those data sets. More importantly, if someone tries to use some crawling tool or whatnot to go after the content store itself, right, we can encrypt it at a DoD standard. So we've got encryption ciphers that are certified. It's an MFC 140-2C whatever cipher thing. It's something for the Department of Justice, right, and Department of Defense, that ensures it's locked down and not something you can crawl across. Okay? So the way this whole thing ties out, you might have mail, and I'm going to get a different marker. So you might have mail, you might have just typical files, right? You could have anything from different virtual machines, Oracle databases, whatever it might be, and that's going to effectively flow tape drives, SAN snapshots. It could be backup to disk with dedupe. It could be cloud. You guys get the idea. Anything we could potentially write to. This is all now falling inside what we're calling our content store. Now, when we collect this information, there's certain amounts of metadata that get collected with this. The metadata actually happens at threefold. And this will also give you a little bit of insight what we're doing with content indexing as well, right? There's really three layers of metadata. The top layer, it's all managed by the comm service, the piece that's driving our solution. That's what's being protected, who did it come from, time it was protected, the data that lives inside. It's all just high-level job information, job details, right? The second layer in this metadata is then what are the ACLs of the files? Or what are the real attributes of the details that I'm protecting? Who has rights to it? So what were the rights that were on it? What were the last access modified times? Have I done any file system tagging? Extra metadata components that flow with that data. That all gets captured here in that same portion. So whether we're doing backups, archives, you name it there, we're collecting that. The third level then is something that you can turn on the fly, and that's the content indexing component. So if I wanted to, I could come back here, finish off my writing. I have a problem finishing thoughts sometime on the whiteboard, so I apologize for that. If I wanted to, I've got my information from email, from files, from virtual machines. It's all being, say, written down into a couple of different dedupe stores. I could then basically go through and say, you know what, I want to go ahead and pull some of this information out and start doing some retention based on content. I don't want to do it based on full backup job anymore. I want to eliminate this idea of grandfather, father, son from 10, 20 years ago, and I want to start doing retention based on content. So what we're allowing customers to do is we actually have our own control mechanism here. If I can draw a gear that doesn't look like a flower, that allows us to now execute against the meta information and the data that's in our content store, go through what would have been a full backup that you're still keeping for, say, 20 days or 28 days for your long-term retention disaster recovery needs, mine into that, and pluck out different files or different virtual machines or different components of that data set, and now assigning them to the actual requirements of the business for retention. So the key here is we can manipulate against all that meta information that we're collecting as data is rolling through into our infrastructure, and then start allowing the customers to maneuver that in whatever direction they want. Okay? Content indexing allows us to get down to the content that lives inside that data set, do that same sort of component. All right, so high level, this is really what we do when we talk about media management. And this applies directly then into how we're driving virtual machines and virtual machine management as we go forward. I'm going to walk you through that one next. Sound good? Any other questions at this point? No? Well, you guys must be really keeping me honest on the whole. We're going to try to stay as quiet as possible then, aren't we? All right, we'll see what we got next. So virtual machines. One of the key things that we live by when we come to virtual machine protection is that we don't want to follow a one-size-fits-all methodology. Meaning we understand replication works for some guests, but maybe not for others. We know that using the streaming VDP protocols that, say, VMware provides is a great option for probably a large multitude of those virtual machines. But then there's use cases where you might need to drive much higher speed recovery. Or you might need to have much higher availability for the data sets. So through that, we offer customers through this platform multitudes of different ways that you can protect virtual machines, right? The interesting thing here is, and I'll walk you through first what we do from a VDP perspective, and then walk you through how these things tie together inside of our core platform. But what we've really got here, we've got an ESX server or cluster or multitudes of them, right? And inside of this, we've got multiple virtual machines. Could be 10, could be 20, could be 1,000, could be 10,000. We have customers across the entire gamut. Now, from that scale perspective, we really don't really care how many virtual machines you have here, right? We can scale it out as you need for ESX server and manage multiple vCenters, multiple vCloud configurations, etc. What we can do what we can do with just a standard streaming virtual machine protection, probably very similar to what we've heard from other vendors in the past, right? We can effectively take one of these virtual guests, load what we call our virtual server agent. This virtual server agent lives inside one of these guests in what call a hot add mode, right? So we're presenting the SCSI3 software snapshots inside the guest. And we can now systematically go through, communicate somewhere to your vCenter, and discover all the virtual machines that live inside that vCenter. Now, why is that important? We're actually querying vCenter and constantly upon every job, updating our knowledge of what VMs live out there. Okay? We can do this and once we discover them, we can drop them into necessary buckets on the fly. So we do this auto detection, and based on all the different, meta information on those different VMs, whether it's maybe data store affinity, whether it's maybe ESX server affinity, maybe VM name, or any multitude or combination of these variables, and about 16 or 17 others, there's a whole slew of them, we can effectively drop any net new VM or VM that we find in your infrastructure into a defined protection category. Why is that important? Rule number one, when you've got thousands of VMs, you don't want to treat them all the same, right? Because they don't all need to be recovered in the same. So from our viewpoint, we show our customers in an automated fashion how they can instantly classify these virtual machines and then define the actual policy, gold, silver, bronze, platinum, gold, silver, whatever it might be, to each of those different hardware configurations, right? So what this allows us to do is we go out, we discover, choose whatever rules we might need to choose from, and we can show some screenshots on that before the day is out here. We can then ensure that these two VMs, or maybe there's multiply this by 10, maybe those 20 VMs or 200 VMs, are all going to be protected with the standard streaming VDP protocol. So what that means is, when we go to run our backup job, we look to see if there's any net new VMs that have been added since the last time we did a discovery. If so, and they meet this rule, they automatically get added to the protection routine. And then we go off and do our procedure. Now what happens here? No real black magic. We just basically call the VADP protocols much like anybody else will. But we do a lot of interesting things around this, right? We'll call vCenter, and we'll either do this in a serial or parallel fashion. It depends on what you want to do from a customer perspective, right? How many software snapshots can my infrastructure handle without causing production server degradation? So I could do 4 of these at a time, I could do 2 of these at a time, I could do 1 at a time. I could go as high as I think it's 10. We don't really recommend to go much further beyond that. What ends up happening is vCenter calls a software snapshot inside VMware, right? You've got that. We mount it up via the hot add mode if it's in a virtual guest. We then do a change block tracking track and back up just the change blocks off to usually some form of a deduplicated disk device, in which we're using our source side dedupe here in the guest, and that data rolls through your network or goes directly off to your disk for a backup target. So now everything's deduped. It's all deduped globally down here on the storage. We've indexed the VMDK level. So as typical, you get instant bare metal recovery of that VM. We also track the file level information inside of it. So I can pull out a single file out of that backup. I could even pull out, if I wanted to, a single message from an Exchange server that lives inside that backup from the VDP protocol. So we have some real tight integration going to those applications, right? Now, next benefit is if I wanted to get this information off-site, I could very easily replicate this to a different disk target. So remember, CommVault is hardware agnostic. You could use HP and HP servers and EMC storage here, and Cisco and Netapp over here, or whatever you choose to use. We don't really care. All right, we're hardware agnostic. We're going to do this replication from disk to disk. We call it dash copy. It's just a marketing term for really being dedupe aware, right? So our media agent stream, much like our clients are source side dedupe aware, is able to only send the delta changes from point A to point B as these backup operations are occurring. So that means I can have an effective mirror of my information over here, but I can also define different retention. So I could keep this for 35 days. I could keep this for 7 days, vice versa, flip it around, whatever you want to do. The key here is that you're just tracking deltas all the way across the infrastructure. Different sites, using as little bandwidth as possible, right? Now, this...
How are you doing the file level recovery? Is it just like an iSCSI target or something? Or?
Well, so the file level recovery, as we're actually streaming the data off to our dedupe target, we're indexing the information. It's a filter within ESX, or inside the VDP protocol allows us to call that out, right? Yeah, to basically map the files to the blocks, so we know what blocks to pull back to restore the single file.
We that metadata, so we know exactly which blocks of extents to extract for any manual recovery.
Who has to actually initiate the file level recovery?
That could be done by an end user. It could be done by a VM admin through the snap-in, or we could do it from anybody that has access to the console, the main console itself.
Also, any web browser, self-service recovery, any iOS or Android powered device.
That's right. It's made available for those now too.
Can you integrate into the vSphere web client?
On the roadmap, right now there's some limitations as to what's allowed in terms of plugins. So we do have our vCenter client plugin available for file folder level recovery. Also just introducing the full VM recovery VM plugin. But definitely on the roadmap once that's available to us.
Is that the thick client or web client?
That is the thick client.
That's the thick client, yep.
John, if you don't mind, that's one thing I just want to jump in and add here.
Yeah, absolutely.
As part of this discovery process and streaming process, we also have built in a lot of intelligence around how we choose the VMs and load balance the VMs. And what I mean by that is you just don't take, okay, these are the first 10 VMs in my backup, let's stream them all out. We'll actually examine which VSA proxy or VSA or virtual server agent does it have visibility into the storage. Is it on the same subnet? We will ensure that the proxy selected for that data movement is the most optimal proxy. Additionally, with the impact on those backend data stores, we'll also take a look at all the data stores that those VMs reside on. So if we're going to do 10 VMs at once, we're going to eliminate the chance that all 10 of those VMs come from a single data store, because that'll be a lot of load, they have some stack reserve issues. We will actually stagger those VMs across the data stores, and think of it as we round robin across those. So not only moving that data in an efficient manner, but limiting the amount of impact on that production environment.
Is there a maximum per proxy or agent or whatever you want to call it, like a maximum number of VMs? I mean, I know you can only do storage at one time, but like, is there a maximum to the group?
There's not a hard maximum, but almost like that bell curve. Once we pass that point, we'll actually see that concurrent throughput start
to fall off. Mm-hmm. Usually, we find customers try to cap around maybe about 200 to 250 VMs max per proxy, and you could go further than that. It also comes down to what technologies you're using, right? So the next point I was going to lead into here is snapshots. Right? I mean, this sounds great for a traditional kind of VM level protection, how we do things. But what if I need data that's recovered, faster? Yes.
Before you go into that, you say you can do it by operating system, ESX host, VM name. Okay, I use complex names, so that actually won't work for me. Do you do it by resource pools, VApps, folders, port groups, network switch names?
So not on the network side, but pretty much from any of the standard default displays that you can see in vCenter. So, template and folder view, you can use any of those affinities. Data stores, data store clusters, you can use those.
Do you do by application?
Not by application itself, yeah. Well, we're not mining into the VM to find out if SQL lives in that VM. That would be something that we would...
application I define in BCOps, for example.
Oh,
or
that's not in there right now, yeah. Yeah, it would basically, like John's saying, it's basically the basic vCenter views that you would see as you kind of walk through your vCenter tree for what options you can choose from.
So actually it could have like an application that spans many of those views, and I could be missing VMs with different protection policies or none at all, and that could be the critical piece. So now I have doing restores, and I have like a third of my data.
Understood. Yeah, we would be looking for a common affinity across those. So one thing to note here is we can also combine these affinities. So it just doesn't mean something in this VApp or something in this resource pool. You can get very granular and saying, bring me back a list of any VMs that reside in this data store as a member of this VApp, possibly residing in this resource pool, and so on and so forth.
Yeah.
So the rules can be very complex as for targeting for inclusion or exclusion. But yes, to answer your question, there does need to be some affinity that we can pick up off of in order to populate those protection policies.
If you want it to be automatic, right? Otherwise, you could manually do it as you're adding VMs in that specific application that might span. But to John's point, if we don't have something that we can tie off from an affinity viewpoint, you know, if you're not able to tell us how these apps work together, we're not physically walking through and creating some map of your VMs of what's actually working together. We need some help from our customer to help define that solution.
Tools already exist to do that, but you're not tying into them. The other thing is, how do I know what isn't backed up?
That's a great point. So on top of being able to discover all the VMs, we'll also show you what's not being protected.
Okay.
So
it's a simple query where we can say these are the VMs in our content that we're protecting versus what is actually residing in vCenter.
correct.
And do you back up the network information, not for each VM, within a VApp, and also, if I'm using vCloud Director, within my cloud tenant?
I'm sorry, could you repeat that last portion?
Do you back up the network information, not associated with each VM, because that's just a little label in the VMX file, but the networks inside of VApp, the VApp definition of a network, and a cloud tenant's definition of network. Because if I have to restore the whole kit and caboodle, I don't have the time to recreate it, because I'm probably doing about 40 million other cloud tenants.
Understood. So yeah, the VApp metadata is collected along with the network information. So currently,
what about data? I have multiple VApps that represent one tenant. Do you have the data that goes between the VApps?
That would be collected at. We need to check on that, but that actually would be correct at the word VDC level. But everything from that level on down, we are collecting all of the metadata, including the network information.
Yep.
Does that include storage URL files, pool, clusters?
Resource
that
pool
would be more
information.
on the management side, so we would actually protect that on the VDC level itself, the database level.
Right.
Do you also have the resource pools that they could be in?
I'm sorry?
In other words, can I use this to recreate the entire virtual environment if I had to?
Well, that's backing up your vCenter, right? Or not? I mean, that has nothing to do with the VM as such. That's backing up your vCenter. That's your infrastructure.
These are database.
Yeah.
Which we could protect with.
But having the metadata of your VApps, that's important. I get that. But
And my
your
tenancy
whole
is
infrastructure, that's backing up your vCenter
Well,
infrastructure.
no, because the tenancy data is actually in the vCloud Director database.
Well, yeah, that's what I mean. I mean your infrastructure backup, right?
So with-
has nothing to do with the application.
Yeah, with our integration in VCD, we do collect all the meta information that's stored in the VCD database that goes along with each of those different virtual machines. So you can do vData Center 1 to vData Center 2 recoveries or across VCD infrastructures because we have that meta information that we can supplant back in. That's at the top level VCD database. As far as underneath that and all the different sub layers, that I'm not sure. I'd have to get more detailed on that configuration.
We actually have as mentioned, the vCenter database or the VCD database. We have to protect as well with lines.
Yep.
Now, talking about restoration, if I'm talking about just standard backup of a VM or a VApp, and I know I can restore it back to vSphere, can I restore it to Hyper-V, Xen, KVM, and actually have it run?
That towards the end of the session.
We'll talk about that a little bit later today. Yeah, yeah, a little bit later. Right now, no. Right now, no.
So you said the restore happens to another virtual data center that we thought was right?
Right, they're the same, or you could do it to an alternate. Yes. Yeah, yeah. The key there is that we're collecting that meta information so that when you go to actually stamp it back into a vData center, you have all the core components that tie it back into the vCloud infrastructure, so you can actually bring that VM live and have it active right once the restore is done.
Could I restore that back to something like BlueLock, or is it done over, if that's the case, do I do that over the vCloud connector, or is it done through you guys?
The restore would be done through us as we're linking into the infrastructure that lives inside that VCD setup, right?
Okay.
Yeah, so no integration with the cloud connector.
Yeah.
How many cloud providers do you actually integrate with today?
I don't know for sure off the top of my head.
So pull it up in 2 seconds in our online documentation, but yeah, there's definitely a few out there.
Mm-hmm.
Okay.
Yes?
You mentioned your platform's extensible. Could you do something like orchestrate test restores in sort of like a sandbox?
Absolutely. In fact, that's one of the key use cases for why customers go this route or leverage CommVault, right? So we have the ability, when we do restores, it's not just a single VM. You can actually choose multitudes of ones across different data stores, different configurations, and restore them all at one shot, right? So that way you're not going back and recreating these operations. The other great part about this is, and I'll really kind of showcase this when we get to some of the snapshot components and some of the array replication integration we have. When we go to do the restores, you can restore it into same data stores, different ESX hosts, different data stores. Makes no difference to us. It can be fenced off as long as we have the actual access path to drop it back in. You can then set it live and fire it right off from there. We'll also track all the unique identifiers, change names, all the SID numbers, so that you can actually bring it up as, could be VM as you backed it up, and be VM prime when you restore it, and you can have them running side by side next to each other. Okay.
Does that do it do you guys do it automatically? Do you do that restoration testing on a regular basis?
You can schedule it to be as frequent as you like. It's not automatic like it does the whole thing, but you define the policy for how you want it to work automatically, and it will flow through 100%.
Well, does it just restore the VMs, or does it actually test the applications within the VMs and ensure that that they booted and run properly?
So it will power them on, and you'll see them come back as live. If they fail to boot up, we'll get an error on the restoration. So we'll get an alert if it does not boot up. Now, it may not mean that all your services inside that guest are live. For a need like that, what we have, and what we launched in Simpana 10, we have a workflow engine that we can tie together with a lot of these components. That workflow engine allows us to do any external or internal commands that customers would typically do manually, and basically allow an automated routine to double check all those procedures. So if you knew you had an app that meant these 4 services had to be live, and I'd have to run a simple query to validate that test was good, we could schedule and automate the entire restore mechanism to a different ESX server in a DR test environment. And then once that restore has been successful, the workflow would then initiate the command call to validate these 4 services are up, then execute this command query, and if that comes back good, then it'll marker as the workflow was successful and give you a report, and basically an automated report notifier that was successful.
So does this workflow tie into what? VIX? Does it tie into VIX? Does it tie into an application API? Does it run PowerShell? What?
So it can do any of those. It's an XML format that you can call from a command line, or it's an XML format that we're building that can make external script calls as well. So you could have a workflow engine call our workflow, or have our workflow call another workflow. Does that make sense?
Yeah, sort of.
So the short answer is yes.
Yes. Yeah. Can you run an email against it and see if it bounces or not? Yes.
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 Yeah.
But you have to write that code. You don't provide the code to test every application.
Which is good.
Yeah.
Which is good.
Yeah.
Because if they did, they'd never have a product.
Exactly. And actually, we've had customers that leverage this now for simple things as well as some very complex things. One of them at what we called our virtual trade show that I think was 4 weeks ago, they had stated it's the best feature in Simpana 10 that's not talked about. Just because it is somewhat complex, right? You have all these options, but when you really use it, it's incredibly powerful for what it can link in, especially in these disaster recovery test ideas.
What if I have a problem with just a single device dies on me? It's kind of critical to get in my development done for agile, doing an agile sprint, kind of critical for the sprint. And I want to just boot up that one device somewhere in a cloud. How can I just do that one device in the cloud within 15 minutes?
So when you say one device, is it one VM or?
Nope, one host.
One host?
Physical server, one whatever.
So.
Could be an iPad. I don't know. I don't care. It's one device. It's dead. I need a new one.
Mm-hmm. Well, from
the simplest one we have today, and I know Don didn't get to yet, was with our IntelliSnap offering, where we can on the fly take any of those snapshots, feed the CommVault GUI, mount up that snapshot, and access that VM. I mean, obviously, there's some differences between storage vendors. It needs to be writable, but you can, within minutes, mount up the snap for that VM, and then actually fire up that VM off of that snap top.
But to your point, device, right? We have to support what you want to fire up. So if you want to recover an iPad, I'm sorry, we don't back up the iPad. We let you use it for access and creating information and putting that information back.
Android tablet, all right.
Yeah, we can't do the Android tablet either, right?
You can't run an Android
Yeah.
tablet in AWS or anything like that, can you?
Well, what if you're
Directly, bare metal?
well, the question probably is, if it breaks and I take a new one,
Yeah.
Can you restore it?
On the like an Android tablet,
Any of them?
because we're not backing up data off the tablets, no. If it was a physical server, virtual machine, yes. Right? Laptop, yes. And the reason we're not backing up data off tablets as part of our edge is, for the most part, there's already solutions across the board, especially for the personal use on replicating your pictures and keeping all that available, right? We leverage it more from a business view of allowing you to have access and information that's getting generated on your MacBook or on your HP laptop or in your virtual desktop that's back at corporate, and allowing you to get access to that information from, basically normalizing that experience, whether it's an iPhone, an Android, a BlackBerry. You have that capability across the board.
Well, say it's one ESX host or a set of blades. One chassis dies. The problem is now you have to make a decision. If you don't have the spare capacity sitting inside of your own data center, you have to go somewhere else to get that spare capacity. So you're tying into certain cloud providers that you have. Can I rapidly get data into that cloud provider so I can get the stuff up quickly? Or do I have to wait for a replication cycle?
You can get it there as
Depend on your bandwidth and
Yep.
other things.
Well, I understand it depends on my bandwidth, but does it replicate my data from wherever you're backing up locally and have another copy out somewhere else?
So we have a number of service providers that will, in this setup, this could be in a service provider.
Okay.
And if that's in a service provider and they're basically giving you DR as a service inside their data center facility, then they can automate the recovery of that information. The moment you lose that ESX rack, they can potentially have it available in seconds at the secondary side. And the reason we say seconds is, this sounds all good and well, but let's go to the next level. We start talking high-speed recovery and some real needs to, leverage that storage infrastructure at a more critical layer, right? So let's say this is backended by NFS with Netapp, for example. All right, so I've got a lot of VMs inside the NFS for Netapp. What Simpana allows us to do here, so of course we're talking to our vCenter agent that talks to vCenter. We can also talk directly to this Netapp storage box that's driving the NFS. When we communicate here, instead of doing the streaming backup, what we'll do is we'll actually calm all of the VMs that are in your associated subclient. And instead of doing that traditional, all right, change block tracking, send the blocks, we're going to call the storage array when each one of these are calmed and snap the entire LUN, or the entire volume in Netapp use case, right? Once that's done, we release all the software snaps that occurred from vCenter inside the ESX server itself. And now we index at the VMDK level, or the NFS level, all the different files that we have stored there. So we have an indexed view of all the VMs that live inside that array. Great part about this is, at any point, we can automatically mount that guest. If you want to do a single file restore from a VM that lives in the snapshot inside the Netapp, you can choose that point in time. It'll mount the snapshot back to your ESX server, do all the unique naming modifications, and allow us to instantly browse and grab the files and restore them back to your production host for a single file access. All from that one snapshot. And then we'll allow you to define how many snapshots you want to keep, right? Maybe it's 7. And then here's where things get even more interesting. Say at this DR site, I had another Netapp box. Well, as you guys probably know, I can use my Netapp toolkit with SnapVault or SnapMirror to replicate deltas nightly, hourly, on the fly, from one array to the next. Well, part of the benefit that CommVault's done with Netapp in this use case is we've tied into Netapp's infrastructure through OnCommand so that we can actually execute this entire procedure through our software. And the benefit here is that on both sides, every single snapshot will be indexed. You can leverage their technologies like FlexClone to instantly mount and go from a recovery aspect and have those VMs instantly up and available. So we have a service provider that does this for customers, by the way. They'll stand up Netapp infrastructure to basically be a vault or a mirror target, and they'll retain 30 plus snapshots for versioning wherever their customer requires what they're paying for, and they'll run disaster recovery for them. And they'll do tests where they basically take that point in time, register it back up their ESX host in their data center, and showcase the apps are up and alive, and validate that for the customer. Now I could do this also if I had 2 different data centers myself. I could also cross back, right? Have data center B go to A go to B. The key here is data's off-site, you're keeping versions, you're ensuring all of your guests are consistent, you're also ensuring the applications that are Windows-based are also consistent inside those guests. So you've got that data available at both data center locations. You're not buying more backup storage for, more storage for backup. You're leveraging your Netapp methodology, if you're buying off on their SnapVault, SnapMirror methodology for data protection, and you're overlaying that whole data management indexing view on top of it. So it's a use case where the hardware and software platform truly meet together to enable this high-speed recovery on both sides. At any point, we can choose these snapshots, mount and go. We can also do Netapp Snap Restore recovery. So if it's a 200 gig VM and only 20 gig is changed, we're only rolling back the 20 meg or 20 gig that's changed since the last time the snapshot was taken. So it helps drive the high-speed recovery. Does this all make sense? Mm-hmm. Anything, it's probably not anything different you guys have heard. We've been driving this methodology with Netapp for quite a while now. Where things really become now beneficial is some of the new things that VMware has launched, right? So things like change block tracking on restores. We can do those same sort of ideas, even if this isn't Netapp. Say this is EMC, say it's IBM. We can still do snapshots. No. And we could do the change block tracking restores, rolling that information right back into that same ESX server. So again, having that same sort of snap restore functionality regardless of the storage array vendor. Now, where things also get interesting is, well, what if this isn't Netapp? What if it's EMC? What if it's Dell? What else do I do there? Well, we can still initiate the snapshots. And again, do this for those tier 1 or the most critical VMs that you might have in your environment. The real key, though, is if this is Dell or any other vendor than Netapp, because Netapp's the only one we currently support for full frame-to-frame replication, where we have the awareness on both sides, right? We do not go beyond Netapp at this point. What we can do here is revert back to the point, we drive the snapshots, we can take these and mount them up off your production ESX cluster. So if you wanted, you could define a separate server or a separate set of infrastructure where these actual storage points in time get mounted to. So you're eliminating the CPU and at least memory access that your hypervisor environment would normally require during backup. Offload that off host, and still drive your dedupe and replication topologies with automated restores, again, to whatever storage device on the secondary side.
Some storage devices don't like you to just mount a snapshot of a data store.
That's correct.
Because of the naming convention of the data. Sometimes you have to delete the original one to get the second one online. Got any comments on that? Or is that just those types you don't support?
Well, that depends on the storage engine. So of all the ones that we support, that's not a concern, or if it was once a concern, we've managed that in how we handle the devices. So everything from even like on a physical server or even a virtual server, how we're mounting up a snap, if it has the same disk label, same disk unique identifier, we manage those duplicates on the fly. It's part of how we've done our code, right? What we'll typically say, just because you can do something doesn't mean you should. Perfect example is the EVA. I mean, the EVA, it says you can do 60 some odd snapshots, I think, or 16 snapshots for every one. I think we all know that if it's a high IOP workload, and in this case, if we're talking VMs, it'll probably be a high IOP workload. You probably don't want to go more than one, even if that one snapshot, if you're doing full form backup off of it, because you're just going to kill your production IOP resources. So those are the conversations we enter with customers. If they need the high-speed recovery, we try to make sure that we talk them through all the different ideas from that perspective. Okay.
How deep does the integration with snapshots go on the Netapp side? Because in most situations when you have Netapps that you're replicating to, the target has a significant overhead when you're using that as the target. So how deep does your integration go in terms of throttling back on the snapshot on the target side?
So the actual replicas as they're rolling in. So because we're leveraging OnCommand, we are creating the relationships.
It does have the ability to throttle it?
To a certain degree it does. But that's all the components inside OnCommand. It's not something that we're setting ourselves because we're linking into the infrastructure and componentry that Netapp's made available to us, right?
Okay.
So
whatever they expose to you, you can leverage.
Bingo. And there's some things that aren't normally exposed that we're leveraging as part of the core partnership and development we've done together. But if it's not inherent in how OnCommand allows the relationships and the Delta updates to occur, there's not a whole lot we can do outside of that. Because we're kind of held hostage to how the Netapp replicates its Delta blocks. We're letting the array basically do the heavy lifting. And that makes it easier to support too, by the way.
Now, given Netapp's integration with AWS, are you actually allowing Sympana to manage all that too? As
in, we're talking like ONTAP Edge and components like that?
No, the new, just announced Netapp attaching to
on some of the cloud, the cloud storage pieces. So I'll say, as an aside, we're having conversations to expand the business in other areas. It's not a part of Snap Protect from Netapp, which, by the way, Snap Protect is Sympana under the covers. You guys probably all know that. We're continuing down those conversation paths. There's other business paths we're walking in and talking down with Netapp as well. But today it's just Snap from FAS to FAS. The AWS component is outside for now. Okay. Now, the other thing to bear in mind here, too, is, and I just to roll this through, this is kind of to finish off a couple of thoughts here, and I'll pass over to John here quickly to kind of show some of these screenshots. We can also still put agents in the guests. There are still points in time where that's necessary. The biggest use case is when customers are actually using VMware to virtualize Oracle. Now, the ability to tap in with RMAN to provide table-level recoveries, log management, true database rollbacks, that's real important inside the guest. So whether you're using physical RDMs, whether we've got them under VMFS, those are the use cases where customers will probably still put an agent inside the guest, or in some cases, they might put our replication, CDR, in this guest, and if they have an ESX server on a DR side, put CDR on this side as well, and allow it to replicate near continuous from point A to point B. So those use cases are still there. They're definitely more niche than typical VADP or the snapshot focus, or even the whole replication focus. But it's things we can do from a virtualized perspective.
So, not going to go too deep into this. Oh, by the way, my name is John Fox. I'm a product manager for virtualization at CommVault. Been on here for about 3.5 years. Came on board my first year as a virtualization SME at CommVault. 10 years prior to that, I was a Wintel VMware administrator. Probably about the last 2 years of my life before coming over to CommVault, I spent most of my nights and weekends converting physical machines to virtual machines. So we all know the causes of VMware sprawl. Very simple: physical procurement, very complicated process, change control, getting rack space, connecting it, networking. We know with VMware, we've made that very simple, where we can take that process of weeks, if not months, drop it down to seconds. I need a few VMs, change control, maybe, maybe not. I can easily spin up a few VMs. I know in our labs, I routinely spin up a few VMs to test some software, and I don't need them anymore. I may or may not power them down, but you know what? I may need them again, so I'm hesitant to delete them. I usually, when my hand is forced, is when finally I have no more space. I have no more memory. I have no more storage space. That's what usually forces my hand to actually go ahead and hunt down and reclaim some of these VMs. So obviously it causes a sprawl, very self-evident. Rather than going out and companies going out cleaning up these VMs, there's a lot of fear of the unknown. I don't know if this VM's needed, it's running, what exactly is it doing? I'm not going to delete it. Obviously gobbling up critical tier 1 storage space. So rather than doing the cleanup, what do? We throw more arrays, we throw more disk space at it. Don, if you could do the next one. So very quick, Don already covered most of these. Different methods: streaming VDP, hardware-based snapshots, agent guest, VM replication. But what we are introducing is what about VM resource management and archival as part of the protection process, that cradle-to-grave protection. So to touch on earlier, some of those affinities where we can target those groups of VMs, what we can key off of, this is how it looks: resource pools, data stores, data centers, templates, anything inside the folder structure. So this is going to be our main tool in targeting the sprawl, where, primarily, we're probably going to look at those test dev pre-production environments. In some cases, production as well. So the tool, archive tool, consists of 3 different components. The first is resource management, where we can look at VMs, examine VMs using those predefined discovery policies, where we can take a look at any of these particular resource usage, so CPU, disk, network usage. We can take a threshold, period of time. If that VM drops below that threshold for that period of time, we're going to power it down. So, like I said, maybe a great fit for test dev. You may not necessarily want to unleash that in a production environment. We are putting together some preview tools where we can say, hey, if had these policies been in place, we would have powered down these, and you can easily exclude those. Second component is storage reclamation. Great, we have powered down VMs. Could have been CommVault, could have been the owners, could have been the administrators, or some other tool out there. So once we have those, we can say, okay, we have the powered down VM, we do our protection pass, we find these powered down VMs. After a set period of time, we're going to storage vMotion these off of that expensive tier 1 storage down to a less expensive tier of disk, SATA, what have you. Last component is the archiving. All right, another 30 days have gone by. We are going to archive those VMs, removing them from that tier 1 storage. So from the vCenter perspective, we still see that VM. Essentially, the only thing missing there are the actual VMDK files. So VM is still visible, ready for reclamation at any given time. Should they decide, I no longer need to recover this VM, they can delete that stub. So once that stub is deleted, we can say, all right, purge that data from the back-end storage immediately after a set period of time, or never purge it. The other is an archive retention policy, where we can say, okay, I've archived some VMs. I'm going to start that clock ticking. That once archived, and if left unclaimed, I will purge not only the stub from vCenter, I will remove that data from the back-end long-term deduplicated storage. Of course.
Good timing.
Hit one more.
Is this tied into VC Ops at all?
Currently not tied into VC Ops.
Because your measurements just seem a little odd. There are some servers out there that stay running for 45 days and power up, do a bunch of stuff, then basically go back to idle, but they're critical to doing counting.
Fully understood.
Or they are ones that have such low compute power but and low networking, but are used almost every day for timekeeping and stuff like that.
Agreed.
And they would, if you don't have networking in that mix, you don't even know what they're doing. They'll look like they have zero compute and zero everything.
Fully agreed. It's not going to be a perfect fit for all VMs. That's why we would use that preview tool to ensure that no needed VMs would be captured.
And bear in mind, those 3 rules, we are not planning on just stopping at just those 3 rules. It will become more enhanced as we continue to dive into it.
It'd be nice if you tied into VC Ops, because it actually gets that usage pattern. And that would be nice to say 0 usage over X number of days based on that.
So remember when we talked about workflow? That could be another component that we could leverage to further enhance the solution set. We could almost take the actual usage patterns from VC Ops and turn the content we're seeing from VC Ops. I'm not sure exactly how we would do it. I'm sure there's a number of ways we could actually cull through the detail, extrapolate what VMs, and then feed it into this type of policy. Another value of how we can kind of link together different control mechanisms, leveraging something like our workflow operation.
And if you do power it off automatically or do whatever you do you actually put some tag inside the VM so I know who did it?
Yes. So tying in right here. So in vCenter, what do we see if a VM's been archived? We're going to stamp it as archived. We are going to sort of currently use space along with the originally provisioned space, so we can see the savings on those particular VMs. Don, if you could hit one more.
Yep, that should be our last one.
So in the annotation field for each VM, if in fact we do archive it, we are going to put a stamp in that, in fact, yes, it's been archived and the date of archive. To answer your question, though, that will be available as part of the backup reports. That, in fact, CommVault powered down that VM as part of its VM management policies.
On those tags, put yes, CommVault. Please put your name of your product right there so I know who did it, not some user.
Yeah, the name of the policy that was used to.
Exactly. You need to put more than just yes.
Tell me who, when, where, how.
Yeah, that could be
That's kind of a
thrown
Boolean,
nuts
though,
to
so
it,
it's
but
hard.
It needs to be there.
It needs to absolutely be there.
More descriptive than yes. Got it.
Yeah,
Got it.
absolutely.
Okay.
And
I mean, I may have a couple of different tools that may be marking an archive field. And if it's already there, find out this tag is already there. And if it's not your tag, create one specifically for you. Because otherwise, again, I could be using another tool that could be doing this, putting their own tag in. You now just overrode it.
Well, does it
That's
use
okay.
does it use
Just a separate
an account?
Yeah,
to actually leverage that? Does it use like a
Service
service
account?
account in order to do that?
Yes, correct.
Okay.
Yes.
Yeah, filter based on that.
Well, that begs the question. It's like, make sure you guys are tied into vCenter. Make sure your service account is unique, please, so that you know
But that's
that.
a customer implementation decision.
But give me a warning that this is not a unique account.
Or give you the option to state how you want it to show up inside vCenter potentially, right?
Part of the installation guide should warn about this, right? And say, hey, if you have other things that do the same thing, please make your CommVault login different than the other thing. Otherwise, it all looks the same.
This is all great feedback, by the way.
So lastly, obviously the reporting, where we can show the total number of machines archived, date of archive, and of course, most importantly, the amount of space reclaimed via an archiving process. And one more, and that's it. Self-service recovery. So we've mentioned this before, via any web browser, iOS, Android-powered device. We now offer the ability to not only recover file or folder level, we've also introduced full VM recovery via these devices. This includes any of those VMs that have been archived.
Thank you. That's all we really had. I know we're already over, so we apologize for running long. We thank you for your time. The feedback you guys have given is great. We're definitely going to take that back and see what we can do to make an impact. Because again, I mean, it's something we just launched recently as of last week. So it's good to get feedback from people that are in the in the trenches, so to speak, and kind of find out what you think from some of these new components and features that we're rolling forward.
All right. Thank you, guys. Thank you, CommVault.